Hello everyone, welcome back to another video where I'm going to try and solve a leet code live with you guys here today. I don't know what the problem is, I don't know what I'm going to solve, I just know it's going to be easy and it's going to be an algorithms question. So let's jump right into it. So we're going to jump to our problems, we're going to do algorithms, we're going to set it to easy, and we're going to set the status to do, right? Because I want to make sure that I at least work through what a lot of people manage to work through first before jumping into some of the more difficult stuff. And I think we are at this problem today. I apologize in advance if I seem a little bit off. Half of my face is frozen. I just came out of a root canal appointment, but let's just do this. All right, so we're going to count the number of pairs with the absolute difference k. I'm going to bring this back over here because I want to still see most of my code. Okay. We have 3 test cases here, and it is an easy 1.1k likes and 24 dislikes. So, and we have a hint this time, so we don't have to jump straight into the solutions. It's a question that you will see with companies, but that's hidden behind a pro feature that I don't have signed up for. So, question states, given an integer array nums and an integer k, return the number of pairs I, j, where I is less than j, such that nums I minus nums j is equal to k. And the value of x, the absolute value of x, is defined as x is greater than 0, negative x if less than 0. What does that mean? Right, so is it the absolute value, or am I returning a negative integer? Well, we'll have to find out. We'll see here. Nums 1, 2, 2, 1, and k is 1. Output is 4. And the explanation is the pairs with an absolute difference of 1 are 1 and 2, 1 and 2, 2 and 1, and 2 and 1. I see. So it's just we care about the absolute value because we care about the difference, and we don't care if 1 minus 2 ends up being negative 1. It's the same thing as being as saying 2 minus 1, because that ends up with positive 1, which is just 1. Okay, 1 and 3, k is 3. 1 minus 3 is 2. That way we expect an output of 0. And for the last case, we have 3, 2, 1, 5, and 4. And k is 2, so it's 3 and 1, 3 and 5, 2 and 4, so on and so forth. And it doesn't seem like there are much else here. So the length of our array can be up to 200 values. The number individually can be up to 100. And then k, the difference, can be up to 99. Let's see. Cool. Let's start this out. So what are we getting passed? We'll give ourselves a little note here so that people understand what's happening. We're being passed 2 parameter arguments, I'll say, because they are at this point arguments instead of parameters. We are creating 2 parameters but being passed 2 arguments. One argument is an array of numbers containing only numbers, so we don't have to concern ourselves with, special characters, letters, because this isn't easy, so they just made it easy for us, and we will only concern ourselves with numbers. And it won't be nested arrays, right? So I won't have to reduce an array within an array to make sure that it reduces back to a number. I'm just going to be dealing with values. And I need to return something very specific. I'm going to be return the number of pairs that when you subtract indices in the from the first argument, they should produce the second argument, which is k. Right? And that's what we're going to return, the number of pairs. So the number of times means if we're returning the number of pairs, we're going to need to do a quick thing. So we'll do a counter for the very start from the very beginning. So create a counter for the total number of pairs, right? And we'll say let pairs, and it is a number, equal to 0. So then what do we have to do? Once we have a counter, we're going to start iterating. We're going to have to start stepping into our array. So step into the array, and start calculating the difference between the current element and the next element, right? So we'll use that with a loop. So we'll say for let I is equal to 0, I is less than nums.length, right? Because we want to go all the way through. And why am I saying, you know, less than? Why am I not saying less than or equal to, right? Because if this array has a length of 4, nums.length will end up being 4, right? That just gives me back a value. But knowing in JavaScript that your indices start being indexed at 0, arrays start being indexed at 0, if we hit 4, then 4 ends up being outside of the array, because this is index 0, index 1, 2, and 3. So if this reduces to 4, 3 remains to be less than 4, and we will never exceed the length of our array. Okay? So when I is 3, it is less than 4. It is the last index, and that means we have iterated over the whole array. Cool. So now that we have stepped into the array, we need to start doing the next step, which is a comparison, right? Which means I'll need another iterator, because I need to determine, like, the first loop will always be on index 0. I want to then compare index 0 to indices 1, 2, and 3, right? And so for me to start with that, I'll need to use another loop. So use another loop to compare your current index to the next index, okay? And so we'll say for let j is equal to what? I plus 1. I plus 1. J is less than nums.length, and then j plus plus. And so why did I start j at I plus 1, right? Why didn't I just start it for, let's say at 0, right? Because let's go through this loop, you know, together. If I is 0, and then we compare it with everything here, first, if we say I is 0 and j is 0, we're comparing 1 with 1, which we don't want to do, right? So then what I can say is I'll start it at 1, right? So when I is 0 and j is 1, the numbers that I'm comparing are 2 and 1. So now that we've compared it, we need to then go through to the next step. So then, you know, 2 and 1, 2 and 1, 1 and 1. We are now done with I is equal to 0. We are now at I is equal to 1. So when I'm comparing I is equal to 1, right, j starts at 1 again, because this external loop, this outer loop, reset, right? So when you tell this j for it to be 1, when I goes from 0 to 1, it will read the internal loop again and start again at 1. And we don't want to do that, right? Because what happens when I is equal to 2 then, right? When I is equal to 2, we are comparing 2 with this 2, because j starts at 1, right? We don't want to do that. So what we will do is we will start our outer loop at the very beginning of the array, and we will start our inner loop 1 index ahead of the outer loop. So the next time when I is 1, j becomes 2, right? And so that solves our problem. So that the next time when we step into 2, we are comparing it with 2 and 1, and then when we step into the next 2, we're only comparing it with 1, right? However, when we get to the end, what happens when we get to the end? When we get to the end here, right, it never runs this inner loop, because when I is now 3, right, this now becomes 4, and this is 4, and what was nums.length? We had already mentioned that nums.length was 4, right? So 4 is less than 4. This is a false statement, right? It's going to just skip over the loop. And so it never goes through the secondary loop, and which is, I mean, we don't want it to, because it doesn't have anything to compare itself with. So let's just undo all of that. And I starts at 0. So now that we have stepped into our second loop and we're running a comparison, right, we can say this: if nums, well, we'll say because we want the absolute value. So we'll use math.abs for the absolute value. This is a function already built into JavaScript. If you are unfamiliar, I would suggest you take a look at it on the MDN, the Mozilla Developer Network, which is your best friend. So math.abs, array of I, right? Minus array, no, sorry, not array, but nums of j. If that is equal to k, oops, the equal sign needs to be outside of the math.abs, which is why you saw my error, right? So let's just make some spacing here so that it's clear. So if the difference of the two numbers is equal to our target, what do we do? Pairs plus equals 1. We will add to our pairs. Once we have gone over our full loop, right? I'll write a note here just so that people understand what's happening. If the difference in indices is the same as our target, add to our counter. Great. Okay. And once that's done, what we want to do is we want to return the total number of pairs, right? And we want to do this outside of our loop, because if we do this inside of our loop, before we step into our next iteration, it will break the loop since we have a return. That's why you want to stick your returns outside of the loop. But let's see. I don't know if I see any issues with this code because I just built it. I think the logic is sound. Let's try running our code and see what happens. Great. Case 1. Output 4, expected 4. Case 2, output 3, expected 0. Yeah. Case 3, 2, 3, and 3. So it looks like it works for our test cases. Let's try submitting it. Now, that being said, what I'm going to do is I am probably going to run into an issue with runtime because of all of these comments. As we have discussed in a previous video, comments usually will slow down the and console logs will slow down the compilation of your code. But I don't really care too much. Beats 60.42%. This is just an arbitrary number. It really depends. If I click it again, right, you will see here that these numbers will change. Right, look, 164, they've swapped places. So it doesn't really mean anything. But can we improve on this code? I think we might be able to improve on this code. We might be able to use a reduce function. Because when we have a reduce function in here, how would I go through and reduce this function if I wanted to? A reduction would be, you would want a loop and then reduce, I see, instead of the internal, loop. Okay, well, we'll see if I can find a solution here, because we just brute forced it. This is probably not the best solution. We'll see if we can find a reduce method that will replace our nested loops, because this gives us an O of n squared solution, right? Simple JavaScript solution. Look, there's an O of n solution using a hash map. Okay. Okay. Right, so they have the hash, and let nums count to 0, yeah. Let n of nums, so they're iterating over their hash map, or over their original array, and they are creating like a counter. So this is instead of the I or the J in our question. And we have here, so if hash n count plus equals hash n, right? So what does this mean? So if hash of n exists in this object, count plus equals hash of n. Hash of n minus k, right? Then hash of n minus k, hash of n minus k plus equals 1, hash of n minus k is equal to 1, hash of n plus k plus equals 1, hash of n minus k, I see, and then return count. So what's happening here? So this is a ternary operator to determine if the difference exists in the hash map, right? So when, let's say 2, so if this is 2 minus 1, if we're going by the indices, so our first array was 1, 2, 2, 1. So let's just start with our first index, 1, and the difference was 1, I believe. So 1 minus 1, hash of 0 should not exist in here. So what it is doing, it's saying hash of 1 is equal to 1. Hash of 0 is equal to 1. So, and then we'll do the opposite. We'll say 1 plus 1. If hash of 2 exists, then add 1. Otherwise, set it to 1. And what is it doing here? How is it finding count? It's finding count because of hash of n. So because of this loop, this one is really clever and neat. Brilliant. So this was a very unique solution. I wonder why they decided to go over and do a check of the difference. Well, I guess it's because of the absolute value, since they're doing a difference of the sum and an addition of the sum. If it was the absolute value, let's see if we can find a different solution that's a little bit easier. 2 approaches, another O of n solution. Right, so this was our double loop. So they went over the map and they said, for let I of nums, if there is a map, add to it, otherwise make it 1. And then nums I minus k. I see. So it's just determining to see if the difference plus equals count num I minus k. So this is the value of that idea of the map. Can you explain your thought process in the second example O of n? How did you figure that out? Yeah, that's what I'm wondering. Like, how are these people figuring this out? You know what we'll do is we'll do this. Let's go back to our solution. I am going to, everything in here, just boop, and do this. Paste this here. I have a map, right? I'm going to console log my map here. Okay? And I want to see what is happening here. So I'm going to put this here, enter, x, this here. Oh, actually, you know what? And we'll do another console log here. Console.log map of nums of I minus k. Nums of I is just, okay. And we'll see what this is. We'll say, call this 2. We'll call this 1. Let's run this and let's see what comes back. Okay, so we have an object with 1 twice, right? And 2 also twice. So when we first iterate, we have undefined and 2. Then we have 2, 2, undefined, and 2. Okay. Let's just put this here. Trying to see what's happening in this secondary console log. And we'll add count since we're adding to count before this. Yeah. Nums I minus k. So what's nums I? So nums I is 1, and k is 1. So that's 0, and it shows up 0. So then we step into the next time, because 2. So nums of 1 is 2, and then minus k is what? Is 1. So map of 1, yeah, add to the count. Yeah. Okay. So we'll do this. I, so that it's a little bit clearer. Right? So when I is 1, I is 0, we don't have anything in there, which is correct, because 1, like 1 minus 1 doesn't exist in our hash map. The only numbers that exist in our hash map are 1 and 2. When I is 1, nums of 1 is what? 2. Minus k is what? 1. So 2 minus 1 is 1, and then map of 1 exists. It's right here, right? And that value is 2. So we are adding that to our count. Okay. Then we step into our next vision. Now I is 2, or our next iteration, sorry. Now I is 2, and nums of 2 is what? Also 2. And 2 minus 1, again, we'll add it, because that's our value. Yeah. Okay, let's see our test case number 2. Number 3 might be a little bit helpful as well. What's our k for number 3? K is equal to 2. So anytime let's do this. Will this work? No, this is going to show me an error here. What will this show me? Yeah, okay. Okay, this makes it a little bit easier. The difference is 2 here. The difference is 2 here. The difference is 1 here. The difference is 2 here. Map of 1. Map of 1 is what? 1. So let's do this from iteration 0. So we have nums of 0, which is 3, minus 2, and that's 1, right? And if map of 1 exists, which it does, right here, we're going to add that number to count. Okay. Now, why is count stuck at, oh, count is 2 here, count is, okay, yeah. Now, let's go into the next iteration. Let's go when we see that I is 3. So when I is 3, nums of 3 is what? 0, 1, 2, 3. So it's 5, right? And it's 5 minus 2, which puts us at map of 3, and map of 3 is also 1. And that's why we see 1 here. And so that's why count becomes 2. Okay, I see how this is starting to work out. We're just checking to see if that number exists in the map that we have already created. And if it already exists, then the difference will be what we are looking for, and we add it to the count, and then we just return the count. Okay, fairly simple. What I'm going to do is I am going to do this, but I will keep my original solution, because this is not my original solution. but it might be helpful for those viewing the video to see what I just went over, to have access to this code, and to play around with it. So thank you so much for joining me today. Today was a little bit of a shorter video. It was an easier lead code, as easy should be. I'm not complaining about it. Hope you learned something here today. Hope you got to see a little bit about how I would approach a question like this. And I appreciate you viewing this, watching this video. I'll see you at the next one.